So this is the start of the next topic, which is going to be on acids and alkalis. And there should be two different lessons or two different videos made on this topic. So the first thing regarding acids and alkalis is understanding that what we'd like you to be able to do is some practical activities when you're in school. We've also in this presentation included a way that you might be able to detect acids and alkalis at home. But what we want you to know is how to detect acids and alkalis or bases and how to measure pH. So before we start this, what we'd like you to do is if you pause the video and write down what you think an acid is, what you think an alkali is, and the names of any acids or alkalis that you are aware of. And once you've done that, if you press play and allow the rest of the video to go, you can see how correct you were on your definitions and if any of the acids or alkalis that you've come up with are ones that we talk about in this lesson. Okay, so hopefully you've taken the time to answer those questions. What we're going to introduce you to is the fact that chemicals can be described as being three different things on a scale. So chemicals can be acidic, acids, they can be neutral, or they can be alkaline, which would make them an alkali or a base. Acids and alkalis are sort of the opposite of one another, and anything that's not an acid or an alkali would be described as neutral. Acids and alkalis are all around us and they're very useful. So I think a lot of people, whenever they hear acid, think of it as something immediately that's bad. But acids are really important and they're really useful in the world around us. Alkalis are, it's probably a word that you might not have heard of before, but an alkali is just a chemical that is opposite to an acid. Now, acids in your home. So you will find acids all around you. A lot of foods contain acids, particularly fruit and vegetables contain lots of acids. Fruit juices definitely contain acids, and some skincare products, particularly things for your face, tend to be acidic. So there's things all around you that are acids. And two of the most common acids are citric acids and acetic acid. Citric acid is the acid present in things like oranges and lemons. It's also on fizzy sweets. The sugar coating on the outside has some citric acid on it, which is what gives them that fizzy quality. Acetic acid is the acid in vinegar. Alkalis in your home. Now, alkalis, again, are very common in your home in the form of cleaning products. So soap is an alkali thing, as is washing up liquid. Washing up powder for the washing machine for doing your clothes is also an alkali. Bleach is a very strong alkali. But also some tablets that you might take, so antacids, so things like Rennie, if you have heartburn, that's an alkali, and it's an alkali because it counteracts, it's the opposite of the acid in your stomach, and it helps to control the acid in your stomach. Whereas soaps and cleaning products, the alkali helps to clean things by removing bits of dirt off surfaces. Now, most of the alkalis that are used for soaps are weak alkalis, so that's why they're safe. There are some that are stronger, like I said, bleach is a very strong alkali, which is why it's very dangerous to get bleach on your hands. Now, as I said, a lot of people think that acids and alkalis are dangerous, but the truth is, too much of anything is bad for you. And so it's only when acids and alkalis are too strong, or if there's too much of them, that they are a danger to you. When they are very strong, both of them can cause burns and serious damage. However, most of the acids and alkalis that you will encounter in your life will be absolutely safe to use. So for example, fruit contains acid and fruit is good for you. Similarly, toothpaste is an alkali and toothpaste is something that you hopefully use twice a day, if not more, for cleaning your teeth. And so obviously that is not something that's bad for you. So acids and alkalis are not something to be immediately afraid of. And there are things that you just need to be cautious of because they sometimes can be dangerous. And so it's really important, particularly when you're doing experiments, to listen to your teacher about any safety advice for the acids and alkalis that you might use. Now, some of the most dangerous acids you might use in the lab. The three quite strong acids are sulfuric acid, hydrochloric acid, and nitric acid. And they can be very dangerous if they are very strong, if they are very concentrated. And acids, strong acids can be found in batteries. So in normal batteries, so AA's, AAA's are typically acids. Lithium batteries don't tend to be as acidic, but the battery in your car is filled with acid. It's actually got a lot of sulfuric acid in it. So it's really quite harmful for you to touch a car battery. And the reason why these acids are dangerous is because they are concentrated. They are concentrated, they're very strong. When you work with these acids in the lab, they will be a much more diluted down version. And later on in this lesson, we'll learn what dilution of acids and alkalis means in terms of how strong acids and alkalis become. Now, the next question you might have is, well, how do I know if a chemical is acid, alkali, or neutral? And in order to do that, we need to use something called an indicator. And the most useful indicator we have is something called universal indicator. And universal indicator is a chemical that changes color depending on not only if something is an acid, alkali, or neutral, but also on how strong that acid or alkali is. And so universal indicator will change a range of colors. So on this picture at the bottom, you can see that in a strong acid, it is red. And then as the acid gets weaker and weaker, it could be orange or yellow. Neutral chemicals will turn universal indicator green. And then alkalis can turn blue. And what's not shown on that diagram well is that quite a lot of them, if they're very strong, will turn a dark purple color. So whenever, if you're in the lab and we are trying to test chemicals to see if they're acid or alkaline, the setup that we would do is we would use a dimple tray. Now that's just a rectangle that's got some circles on it, and you can put chemicals in the circles. What you would do is you would put the material in one of the circles and then using a dropper add some universal indicator to it to detect it. You would need to make sure you're wearing goggles because you are working with acids and alkalis and they can be dangerous to your eyes. Now, you would be given a series of different things to test, and if you did that, here's some of the results that you would get. So salt, so seawater, would turn it green, which would mean it's neutral. Fruit juice would turn it red, making it an acid. Soap powder, so soap powder is the powder that you would put in the washing machine to wash your clothes. It would turn it blue, meaning it's an alkali. Sugar, you need to add a little bit of water to the sugar, but if it works, it should turn the indicator orange, meaning it's an acid. Vinegar will turn it red, making it an acid. Brillo powder, which is a cleaning product, would turn it purple, and that's a very strong alkali. Fertilizer should turn it yellow, but yellow means it's a weak acid. Lime powder. Lime powder is something that you will sometimes add to soil. It is a strong alkali and it would turn it purple. Toothpaste would turn it dark green. Dark green is a very weak alkali, and water would turn it green, making it neutral. Now, if you're watching this from home and have not necessarily been in a position to try this experiment, what I've included is a set of slides showing you how you can create an indicator at home. And it is an indicator made up of red cabbage. So you might want to pause the video or maybe take a photograph or note down this if you want to try this experiment at home. So what you need to do is you need a red cabbage and you cut it up into bits. You don't need to use a lot of the cabbage, but all you do is you put some red cabbage leaves into a saucepan with water and boil it. And then you leave it to cool. You filter out the cabbage and you should have a purple solution. Now, red cabbage, that purple solution will change colour. So it's a purpley colour when it is neutral. So it's different from universal indicator. In an acid, that purple colour will turn pink or red. In an alkali, the indicator, the red cabbage, will start to turn blue, and if it's a very strong alkali, it'll turn green and it might even turn yellow. So the red cabbage is pink for acid, purple for neutral, and blue, green, or yellow for alkali. So some things that if you make this indicator at home that you might want to test out, it's good to test out fizzy drinks, particularly lemonade because it's colourless. You can try water. Toothpaste is a good one that you can add to it. Sugar is another one that you can add to it. And if you're very careful, you can try some, you might ask if it's okay for you to try, if you've got washing up powder, to just very carefully add a spoon of washing up powder into it to see if it works. Now, washing up powder is dangerous, so make sure that if you are using that, you ask permission first. And if you are trying this experiment at home, you need to make sure that you've got permission to do it. But it can be quite interesting to see the colours that things change. So in the first part of this video, we looked at the pH scale and we looked at the colours things change. The pH scale, not only does it change different colours in universal indicator, but we can assign the pH scale, we can assign numbers to the colours. And the numbers on the pH scale go from 1 to 14. Now 1 represents a strong acid, 14 represents a very strong alkali, and neutral is 7 and only 7. So each colour represents a different one of these numbers, but red is a strong acid, purple is a strong alkali, and pH 7 is neutral. Now, if you're asked if something is an acid or an alkali, all you need to know is if the pH number is below 7, so if it's 6, 5, 4, 3, 2, 1, it's an acid. If it is above 7, so if it's 8, 9, 10, 11, 12, 13, or 14, it is an alkali. But if it is exactly 7, it is neutral. So pH 7 is neutral, less than 7 is an acid, more than 7 is an alkali. What I just said. So a neutral solution has a pH of 7 and will look green. An acid solution has a pH of less than 7 and the solution could be red, it could be orange, or it could be yellow. And alkaline solutions have a pH more than 7 and they could be dark green, blue, or purple. If we have a strong acid or we have a strong alkali, we might want to dilute it. And diluting something just means to add water, like diluting juice. And when we dilute solutions, we change the pH. Now, if you're able to do so in class, the experiment that you would do is you would make up an acid solution. So you'd be given some acid and then you would add some water to it. And then you would add some indicator to it and see what color it was. You would then take a small sample of that acid that you had and add even more water to it and then check the color again and see if it changes. And you would keep doing that process, making one solution, diluting it, then taking some of the solution you've made, diluting it even more, and so on, and keep checking the color. And you can do that with an acid or with an alkali. What you should notice is that if you have an acid and you do dilution, the color will start off red, and as you dilute it more and more, the color will start turning orange and yellow, and you can get it to turn green, but you can never get an acid to turn blue. With an alkali, what you can do is you can get the alkali by dilution. You can get it from purple to dark blue to a light blue to a green, but you can never turn it yellow, orange, or red. What dilution does is bring the pH closer to 7. So if you dilute a strong acid, you get a weak acid, and the pH will go from 1 to 4, 5, or 6. If you have an alkali and you dilute it with water, the pH will drop and it'll go from 14 to maybe 10, 9, or 8. If you dilute something that's neutral, it will just stay at pH 7. So if you have an acid and you're diluting it, you can go from pH 1 to pH 5, and you can get it maybe to go to pH 7. For an alkali, if you're diluting it, you can go from pH 14 to 10 to maybe 7.